So we have been looking at um, the graphs of ellipses, and today we're going to look at something called a hyperbola. And I just wanted to show you what the difference was. So I'm going to go in my calculator, and you can join me if you would like, and we're going to put in an equation for an ellipse. Let's make that 16. And on this side, it was always equals 1. Okay, so we should know what that one looks like. And it's an ellipse. And when I go to the graph, you see it's centered at 0, 0. We can look at the different radiuses. But a hyperbola has, instead of a plus here, it has a minus. That gives me what's called a hyperbola. Let's look at the graph of it. Let me get the graph. Ooh, why is it not doing a pretty graph? Let me zoom out a little bit. So what we end up with, and this is not the best graph, let me go to, oops, back up. Sometimes it does nice when we do the auto, and sometimes it doesn't. Let's try the auto again. Now I'm going to change the axes to be -10 to 10 and -10 to 10. And let's look at what that looks like. A hyperbola is a double parabola back to back. Now, this one is opening left and right. That's actually because the x squared is first. If I change this instead of the x being first, let's change it to the y. And it opens up and down. So that's the big idea about a hyperbola. So what I want to do is I'm going to stop the sharing and go back to the camera. So I'm hoping it went back to the camera. So what we have on a hyperbola is you have your H and K would still be your center. This is going to tell me how far I count left and right, how far I count up and down. Those are the same, but this time instead of drawing an oval, we're going to draw a rectangle. So let's look at a couple of examples. So this first example, the center is going to be 0, 0. Because y squared is first, this is going to open up and down. The A is the one underneath the X, so that's 3. And the vertical is 4. So I'm going to start, we're centered at 0, 0. I'm going to go out 3, up 4, down 4. This is going to give me an imaginary rectangle. Now, what we're going to do is draw some diagonals in here. So, these are going to be our asymptotes. They're boundaries for the hyperbola. Now, this one's opening up and down. So, it's going to be in this realm and this realm. And it's going to touch the box right there in the middle. Nope. Touch the box right there in the middle. Now, this time, my foci are going to be inside these parabola pieces. So I need to figure out where they're at. Now, for the foci on this one, it's going to be a squared plus b squared, which makes it even easier. So I have c squared equals a squared plus b squared. That's 25. So my c is 5. And if I'm opening up and down, I'm going to add that to my center. And here's one of my foci. And here's my other foci. So my foci would be at 0, 5 and 0, -5. Now let's look at this next one. Still at 0, 0. Underneath the x, we have 4. So my a is 2. My b is 6. We're centered at 0, 0. We're going left and right 2, up and down 6. And we're going to draw our diagonals. This time, x squared is first. So I'm going to open left and right. That means my foci are going to be inside those parabola curves. C squared equals, this time it's a squared plus b squared. So 40, which would be 2 root 10. And I'd be adding it to the x value. This one would be at 0, 0, 5, and 12. 0, 0, 5, and 12. This would be a very, very, very big box. And we would do the same thing. Let's look at one of these other ones, and then that'll be it for today. Because that one's just the same exact. This one has a 36 on the other side. So I'm going to divide everything by 36 and get x squared over 9 minus y squared over 4 equals 1. Center is at 0, 0. Horizontal distance is 3. Vertical distance is 2. We're making a box. Draw your diagonals. This one has x squared in front, so it opens left and right, left and right. C squared equals a squared plus b squared. So C is the square root of 13. We were opening left and right, so we're moving left and right. Tomorrow, we're going to be looking at the transformations of this.